everyone. Welcome to another binary episode of the Day Zero podcast. I'm Spectre, with me is Z. Another somewhat light binary episode with a meme of an Oracle VirtualBox VM escape and a PostgreSQL mem corruption. But also, there was a pretty cool repo put out that involves introducing memory safety issues into Rust applications without using unsafe. So we'll lead off with this one. The repo is called cve-rs, and I'll let Z get into it a bit because he had first noted this, and I think there was a bit of discussion in our Discord on it too, right?
I think there might have just been a little bit of discussion. I put in interesting links, but I didn't actually follow up if other people kind of continued talking about that or not.
I might have confused it with another Discord
No,
then.
I don't see any discussion about it there. So I don't know.
It's probably somewhere else then.
Yeah, I definitely had some discussions about it. And yeah, fun thing with that is, blazingly fast memory vulnerabilities written in 100% safe Rust. And it is legitimately that. In the past, when I've talked about Rust and Rust vulnerabilities, I've mentioned how, there was a use after free in Rust. I think there was some corruption in like core Rust many years ago and many versions ago. But then otherwise, vulnerabilities in Rust have generally always involved unsafe and safe code. Like there's always been the unsafe somewhere in there. On one side of the vulnerability. It's always kind of been there. And so with this case, it is 100% safe code. And what it's going for is more of a problem with Rust like typing system itself and just an unsoundness issue with Rust typing that creates the issue. And I'm going to be honest, since I do not actively write Rust, I'm not like experienced with Rust. I have some really, really old experience with like the very early versions of Rust. But
Like pre
even
1.0.
there, I didn't like master Rust or have like a really good hold in it. So when it comes to this, I'm going to be lacking a bit on explaining everything or being able to explain. But the repository itself does make an attempt to explain in the lifetime expansion.rs, because at a super high level, the main problem is just that they are able to make Rust legitimately expand the lifetime of any object. So if you're familiar with Rust, lifetimes are kind of a big deal where in theory, like you create a variable, it'll start off where the lifetime is, whatever scope you created in. So if you're in like a function, nothing else going on there, like you're not in a loop or something, that variable should last until the end of the function, but you can hand it off. So you can pass the variable off to another function and it can take control of that reference so it actually gets cleaned up when that function returns, or like, they could just borrow it instead. And then there's a whole bunch of things going on with the lifetimes of values. And then part of the issue seems to come down to, or sorry, coming back to the high level issue actually, is just the fact they can expand that lifetime. So even though your reference to something might, or the value that's actually being referenced might have been freed already because its lifetime ended, you'll still be able to hold on to like a longer lifetime to that value, to wherever it's pointing, and thus you'll be able to access that data after it's been freed. So you've got use after free, you've got potentially as values get changed or whatever, you might be able to get like out of bounds access. You can just create all of these memory corruption issues because of a problem when it comes to lifetimes, and specifically when it comes to the typing system reasoning about the lifetimes. So the code here, they kind of have two implementations of the same thing, where they have the lifetime translator, and all that does is it takes a value of that has either lifetime A, lifetime B, and just any type, and it returns it as the lifetime A. And it comes down where it's trying to reason. So this code is okay, this lifetime translator, as long as the lifetime B is smaller than, or like shorter than, it will complete before lifetime A. So all of the lifetime, or A is valid for the entirety of the lifetime of V. Basically, you can then be like, or I think I just got that backwards actually. B is valid for all of the lifetime of A, therefore you can return a value that has the lifetime of B as having the lifetime of A. And then things get messed up when you start talking about special values that are static values that are kind of special in that they have a lifetime of like the entire program. They last forever in a sense. And then that's where there's some sort of soundness issue, which I can't really explain besides saying that along with that some other rusty stuff goes on, they're basically able to take any value and return it as a static value, so as though it has the lifetime of forever, and thus you can just write more relatively common code. If you do want a good breakdown of this, I did find one. So obviously it does talk about it here at the top of the repository, which, especially if you have a Rust background, this is probably going to be somewhat sufficient for you. But I did come across a YouTube video from a seemingly pretty small creator here, um safe rusting safe, and this is from Residual Entropy. They did, it's a like 20 some minute video where the start of it, like first, not quite half of it is focused just on like Rust lifetimes and explaining ownership, borrowing, and lifetimes. Then they kind of build up, talking about the variance. That's where I was talking about how like the lifetime of A and B, if one's longer than the other, you can use them as each other. Well, not each other, but like when one fits that, and that reasoning there. I'm not explaining that very well, but they kind of walk you through building up through all of that code. Really solid explanation of it. Like I was able to follow this and get a reasonable grasp of it. Not well enough that I'm able to retell it here, but well enough that I will tell you to go and check out their video here about cve-rs, because it does a much better job than I'm going to. I made my attempt, but if you want follow up, that's where I'd recommend checking out.
Yeah, I will say what made that video helpful is, like, see, I don't really have Rust experience. It's one of those things where I've always told myself I'm going to try learning Rust soon, and I never do. It's on the eternal back burner. But even as someone who's not intimately familiar with Rust and some of its crazy notation, which you will see if you can see the podcast, is in full force here, with like the lifetime annotation and the variance and all that stuff. But even as someone who doesn't have all the knowledge of what's going on there, the video that Z mentioned, he does some analogies that really make it a lot more understandable to the layman. I mean, I say the layman, like it's still somewhat difficult to track. Like it is complicated with the relationship somewhat, but even if you're not deep into Rust, basically you can come away with an understanding of what's happening in the video, even if you don't appreciate all the nuances of it. So yeah, it's pretty interesting because, like you said, typically when we've seen Rust issues, they involve unsafe. And every time we've talked about Rust on the podcast, that's pretty much come up. And this lifetime thing, it's sort of exclusive to Rust, right? And some people might wonder, like, why do that? It just seems like really complicated and hard to keep track of. And it is. I think it kind of contributes to why can be a bit difficult to read at times. But because they have the lifetime being tracked by the scoping like this, it lets the memory sort of clean itself up, so it eliminates having to manage memory by the developer, which is what creates memory safety issues. And also it doesn't require a garbage collector, which, you know, as everybody knows at this point, garbage collectors aren't exactly ideal. They're slow, they can have issues in their own right. So that's kind of why this issue, you don't really see it in other languages or
Yeah,
anything
like
else. Like it's kind of an exclusive issue to Rust,
something
but it's a
Rust tries
complicated one.
to protect with is like lifetimes and borrowing and all of that, and like tracking who owns what memory is
And
something
doing it in
Rust
like a
does.
prove a yeah, and like proving it at compile time rather than relying on runtime checks.
Yeah, that's the other thing, like the zero cost aspect with Rust, where it happens at the compile time rather than at runtime and doing all those checks there. Like it's very much like a part of Rust's selling point and part of what makes Rust the really cool language, even though it is also kind of annoying to read. And get into all that, but
I guess how I
um
would say it is that Rust can be annoying to read, but it's justifiable. Like there's a lot of benefits you get with that. So
yeah, and
it's not needlessly annoying to read.
yeah, it's not needless. Like they've simplified it how they could. Like it used to even have more complexities to some of the notations, but they have kind of simplified some aspects of that. Of just bringing in the single keyword like much for mutable, some of that stuff. So yeah, I mean, Rust has its rough edges, but still, I thought this was a really cool showcase of basically being able to introduce these bugs in safe Rust. And while I don't think it is the most likely situation that a developer is going to write just like this expand function and do that, this code, seeing how small this code is, where it's just like, some code ends up changing the lifetime. What like in this case, like literally this function just takes one lifetime, returns the other. But you could imagine a more complex function actually doing something and changes the lifetime of it there. And then you could imagine another bit of code maybe leads into the expansion. Like I could, because of how short all of this code is, I can imagine some of this code like being accidentally included. I know Spectre, we before the show we were kind of disagreeing on this point, but to me, and again, coming from the point where we're not writing Rust, so like our opinions are basically invalid on this because we don't write Rust, so we can't really comment on what's legitimate for Rust. But seeing how small the code is just feels like it's possible for developers to not likely make these mistakes, especially because you do kind of rely on having like the static there, which is a bit special here. You kind of see its reference here as being a const, like the whole typing of it to make that special variable feels very unlikely, but it also feels like the sort of thing that maybe, lifetimes get changed around in the wrong ways. You can create some of these issues. Maybe not going for the whole static and forever lifetime, but maybe still some invalid lifetime and being able to introduce some of these memory safety issues. Like this feels to me like we might be able to see some aspects of this actually introduce bugs in Rust code that's sufficiently complicated. But again, I have to preface that with I don't write Rust, so my opinion does not carry much weight here.
So as you said, I did kind of disagree, and the way I classify this in my head is sort of like a toy thing. So the one thing I want to bring up there, and this kind of ties into what you were saying with the lack of Rust experience, I'm not totally sure on this, but I don't know how common it is for developers to manage lifetimes manually like this, because as I understand it,
I don't think it
typically
is at
like the
all.
lifetime, yeah, like you would just leave the compiler to manage that for you. I can't think of many cases where you would need to manually manage the lifetime like this. I'm actually a little bit surprised it's even something that you can manage, like that Rust lets you do. There's got to be some reason for that, but yeah, where I don't have a lot of experience with Rust, I can't comment on that too much. So that's one reason why I think, as cool as this is, I don't think it would really be something you would encounter in real world. But also, the other thing that I was saying to Z before the show was that I kind of compare this to a browser, like attacking JavaScript, right? You're attacking the language, the execution environment, and I'm kind of comparing it to like saying you could trigger a memory corruption issue in a browser by accident writing JavaScript. And like sure, in rare cases, at least back in the day, like you could very well trigger memory corruption with legitimate code. But for the most part, if you're triggering memory corruption, it's because you're doing something that's really, really weird, breaking expectations that were just never thought of. And that's where I would classify this. I feel like this would be hard to unintentionally write into your program.
Yeah, I definitely like I think that's fair. And that's actually a really good point on the browser side because I was talking about how small the code is and like feels like you might be able to do this. But browser has had some very small proof of concepts that are still code that you're very unlikely to reasonably write. So yeah, I think that's a very fair and like good point. And again, without the good familiarity of Rust, I really can't speak about how likely this is, any of this to write. And like you said, the whole lifetime like conversion here is, as I understand it, an area that is not commonly explored or really need to worry about in a lot of Rust. And so even just writing the code may just be very uncommon.
Yeah. I will
Nonetheless,
say anyone who listens that is familiar with Rust, like I would love to see some comments and opinions on this just to see like if I'm, if we're on the right track with how the lifetime tracking works and how uncommon that would be to use in code. If it is a bit more common and we're just naive on that, like I'd love to hear about it. So leave a comment on that if that's the case. But
yeah.
yeah, still like even though I don't think it would be super practical to have these issues introduced in real applications, like it's still a very interesting case. And like I said, I don't really know how well this would transfer to anything else. Like I'm not sure if you could take this away and try to find it in some other area. But lifetime tracking is really complicated. And even when it's managed for you by the language, like it's hard for the language to do too. So
Yeah, and I
it's
guess
kind of
should
proving
also
that.
mention that like this The soundness hole here does come from the implied bounds on nested reference plus the variance. That's where I was talking about with it. Using one thing as another type of object, or well, lifetime. In this case, this issue was like reported as a bug back in 2015. So like it has been known about for a while. Not necessarily used in this way, but at the very least shown and kind of known about for a while as like there's an issue here that is hard to fix.
Yeah, I was actually about to ask, did you look at that issue and see why it might have been still open? Because I didn't look at the issue really. Is it
I
just a
didn't.
case of like they don't really know how to address it because it's kind of a design flaw, I
So
guess?
I didn't go through all of the comments here. I believe it's kind of like fundamentally a different or a hard thing to fix given the definitions of their typing system. It's not like a, I guess, like a fully proven type system, provable type system, but it is their type system that they are using, and so it would require like changes into that. It's because it's a soundness issue. It's not like it's just a really quick bug to fix it. It's like everything is working how it's supposed to, but there's a soundness issue with it where it's like
Yeah, so
not.
so I'm actually looking through the issue, and there's even like these comments were from 2016, but there was even some disagreement on what the underlying like who to blame here, I guess. Not who, but what to blame. Because there's some statements that like it's a problem with contravariance, but then there's another comment here saying they don't consider it to be a problem, like a fundamental contravariance issue, but saying that removing contravariance from function arguments would be a pragmatic way to solve the problem. So yeah, it just sounds like it's difficult to deal with. It's kind of inherent in the design of how the lifetimes work. So yeah, I mean, like we're saying, like where it's so complicated and everything, and it's built into the language, something like that is really hard to change, especially if it's going to change behavior that existing applications are relying on, right? So
Yeah, like
yeah,
it would probably require like the version bump or something to indicate a breaking change.
yeah. So very interesting case, but I don't think it's going to be something that propagates into vulnerabilities and applications. But we'll see. Maybe I'm wrong on that.
Yeah, like my
Like Z
thinking.
said, grain of salt, right?
Yeah, and my thinking on that wasn't that this is going to be like there's a big bug source for everybody, but it is a case of you could maybe
It could
possibly
sneak in.
see
Yeah.
things given like as things get more complex. But same caveat as I've given earlier with regards to my opinion on that matter.
Yeah, sorry. I didn't want to imply there that you were like anyone was saying this was going to be like some major, thing that's going to impact a bunch of applications. Like that's not what I was trying to imply. Uh, but yeah, I don't think it'll really be seen at all. Basically, is what I'm saying. But yeah, uh, I'm interested to be proven wrong on that. All right, so we can get into some of our vulnerabilities of the episode. We'll start off with a VirtualBox one, and as I said, this issue was a total meme by way of the VirtIO net device driver, particularly the VirtIO net control VLAN command. And the great thing about this is it's literally impossible to call in a correct way, and can only be called successfully if you're trying to exploit it. So let's see get into some of the details here.
It's the best exploit scenario to be in, really. Like, it's very welcoming of exploitation. And yeah,
For
that
real,
comes
yeah.
down to the fact that this code, um, basically they have an assert in here. And the idea is, you have a limited number of VLAN IDs, and you do track this max VLAN ID. So in the code, you've got an assert that comes in. You've got the VLAN ID. It's kind of the most important key to this, and you've got a kind of the max VLAN ID. And what they call out here is basically the check should be, make sure that VLAN ID is less than the max number. Whereas instead, their assert here is you VLAN ID greater than max. And what this means here in terms of what will happen with this code is that if this condition here fails, then it will say that it's out of range. So it's only going to say it's out of range if the ID is less than the max VLAN ID.
It's in
So
range. Yeah.
yeah. So I could kind of understand like if you're writing this as like an if statement, why you would get here, like why you would write it like this, because you go assert message return. If you think of that as an if, if VLAN ID greater than VirtIO net max, like the max VLAN ID, do the error, which is it's out of range. So I get that code, but it's an assert. So you kind of need to write it the other way. You want
It's
to
it's sort of
assert that it's
the
less.
it's sort of the same kind of issue that people run into with double negatives. Just like flipping the logic, like inverting it, it's hard to do where you're so used to if statements. And this is a reason, like we've talked about it before, but using assert for security critical checks is just dumb, in my opinion. Like it should never be used, because whenever you see assert, not only do you have that inverse logic where you're passing like a true condition, but a lot of the time, like assert will be a debug only thing where it won't be on a prod build. So it's just I don't know why everyone feels the need to use asserts instead of just regular if statements. I guess it's fancier, but it leads to issues like this.
Well, actually, so using asserts, like, I don't think asserts should be thought of as part of the security system, but it does make sense, like I said, with the debug builds to have extra checks in there that can catch these issues earlier on. To
Yeah, I'm not
basically be
saying get
writing.
rid of asserts entirely. I'm just saying for security critical things, don't use asserts as the only thing.
Yeah,
Yeah.
I think it's going to come down to the application. Like, if everywhere uses asserts, then like that's just how they write these checks that are going to like not return if they fail, and like they'll necessarily exit. I feel like it's fair as long as they're consistent about it. Like you don't switch back and forth, and generally you will see a lot of mixing of kind of the options. Some will do if statements, some will use asserts. And generally speaking, you probably would prefer if statements, so you kind of use the control flow and do something about it, not just die. Although maybe I
It's
should have
like
looked into it.
elegantly what I'll say about asserts, it's like elegantly trying to be lazy.
Yeah, I suppose. Anyway, like what this comes down to is rather than not being able to call this when your VLAN ID is too large, you are able to call when it's too large. And then it just comes down a little bit later. It's going to set it either ends up in one of two cases. Either the command you're using is wanting to add or you're deleting, which will end up using ASM bit set to set the VLAN ID. And or it will use ASM bit clear to set that same bit to 0. So it's effectively treating this VLAN filter as a large bit field that it will set bits on. And the nice kind of thing about this function, the ASM bit set and clear, is that it supports like multi-byte wide values. So you don't just need to send it whatever byte you want to set the bit in, then your bits have to be between like 1 and 8. You can give this, the entire array as they do. And if you give it like 16,000 as your value, as your VLAN ID, it's going to pass that check because, you need to be larger than the max. It's going to pass that check. It'll go ahead and it will set the VLAN ID, or it will go ahead and set like however many bytes. Let's use 8,000 because that's a little bit easier. So it's going to go and set like it's going to go and get like the 1,000th byte and then set the bit in there. Um,
Which
and
is kind of
because of
interesting
that,
because it's not too often you see like an out of bounds bit, right? It's
yeah,
not too often you get granularity at the bit level.
yeah, it gives a lot of access and a lot of control, and it's relative, so you're not initially needing to worry about ASLR. With the bit writing here, we're able to actually start talking about the exploit, which is actually so this was disclosed back in November. So unfortunately, we did miss it. I'm now tracking this resource as yet another source for bugs from Google security. Not necessarily Project Zero, but still some of their security research. But what did drop more recently was their actual proof of concept for this bug, which isn't terribly surprising in terms of how it works. You've basically like they're able to get because this is the bit writing. You've got arbitrary right. You've got arbitrary right within a pretty reasonable range of memory. It is assigned value, so I believe they can go negative also. And we're dealing with a fairly complicated object. We're inside of this VirtIO net object. Let me just see if I can find what line we've got the. Let me just double check what the actual variable was here again that it was writing on the VLAN filter, a VLAN filter. Yeah, so it's kind of deep inside of this function, but it is down here where they've got that as just their uint8 array. Inside there, you've got a bunch of other objects here, a lot of just single values. Although there is also some config and point. This has a pointer type up in here. But anyway, coming back on the actual exploit, you've basically got your write bit. So creates that primitive, which is going to be calling either the VLAN add or delete if you're wanting to set to 1 or to 0. So not very unexpected. He's able to create like the standard write primitives very easily out of that. And then uses a corruption or basically fakes a VirtIO core in order to create kind of their reads by corrupting one of the mentions here, corrupting the pdev, so pointer dev ins r3. Not sure what that is, but they were able to partially corrupt that pointer. They have a very targeted read thing, or sorry, very targeted writes, which creates kind of a type confusion that they're able to take advantage of, so that when they use just the standard PCI read config for the device, like the PCI device associated with this, they're able to get the read off that with their arbitrary pointer, with their pointer, which creates their read primitive, chain all of that. They've got your standard read write, so it's going to be game over. They write a ROP chain, or once they've leaked some variables, offsets, write their ROP chain, kind of a standard thing where it's used, resolves like mprotect, creates executable area that they can jump into, which, pivots and, goes on. So it kind of a straightforward strategy there inside of VirtualBox here. So I'm not diving too deep into that. You've got the actual exploit if you want to get into it. I don't want to get into all the details of VMware. And I also, in all honesty, didn't get into all the details of VMware to explain it all.
VirtualBox, sorry, just to do a quick correction there.
Oh yeah, I'm sorry. I often end up using VMware, so I was saying that, but yeah, this is a VirtualBox bug. We're not like escaping VirtualBox into VMware or something.
So that would be pretty wild.
Yeah, I didn't go into all the VirtualBox details to fully understand the exploit strategy, like exactly what was being corrupted, just enough to understand the gist of this, where they have the right being granted pretty easily. They're able to corrupt the pointer so they can use the PCI reads in order to actually get their reads, and then they just rock to the end.
Yeah, basically a partial override at the bit level. And it's kind of funny, right? Because on the one hand, like where you have the bit level granularity, you have so much control. Like that's as partial of an overwrite as you can get. So in that way, like it's really nice. But also, in order to affect change on the value across more than just one bit, you would have to exploit it multiple times, which, depending on how active like the heap state and stuff is, might be a problem. Like things might get shifted in between your attempt to change multiple bits. So it's kind of an interesting scenario to be in. It's kind of like a kiss curse, there's positives and negatives to it. But yeah, I mean, where you're talking about this in VirtualBox, that kind of primitive is extremely powerful for VM escape. And I mean, VirtualBox isn't really known as the most secure virtualizer out there. It's kind of got that reputation of being weak, especially with these kinds of drivers. But
I will mention, like, this is all within one object, so they're not like going too far out of bounds with anything.
Right. Sorry, that's a good point. I completely forgot about that fact. But yeah, where it's in like Intra-Object, you don't really have to worry about the heap state. Yeah.
Yeah, so that is a huge benefit. That's what caught my eye with this. There were a few other VirtualBox bugs, but when I saw Intra-Object, I'm like, that's going to be a little bit more interesting, because we often see these things that are heap-based overflows where you're going to have to do all the grooming and all of that, whereas this has the potential to be a very stable bug. And I should clarify on one point, because I mentioned going like 1,000 bytes out or whatever. That's what the ASM, like the actual function, would allow you to do. I'm not sure what controls there are on actually what values you can provide for the UVLAN ID, besides the fact that it's a 16-bit value. But I'm not sure what restrictions there, because they do call this specifically an intra-object out of bounds access. So I assume there are some controls there, because I don't think it's actually, I guess that maybe, like, I don't know how many bytes are actually controlled, like how large the VLAN ID would be. But it feels like I don't know, but I don't know what other controls there is kind of what I'm going to leave this at. There may be some other controls on that value I'm also not aware of, but yeah, the fact that this is intra-object kind of makes it stand out as kind of interesting because those are often very dependent on what you're actually exploiting, what the object is. Of course, in this case, there are pointers and there are things to target, but intra-object bugs just kind of stand out because even with like the best tooling, intra-object stuff is really hard to catch.
And
And
something
really,
that you probably wouldn't get with MTE either, right? I mean, we love to talk
yeah,
arrays.
that too, yeah. Because MT with the at best you're going to have each heap slab or each heap like block should be a different have a different tag. Therefore, when you try writing out of bounds, it should detect that hey, this isn't where it should go. So being intra object makes it a cool attack too.
Yeah, it would evade even like hardware sanitizers, which I don't really know if you'd see in VirtualBox anyway. But yeah, it's a rarity and it's a rare gem.
Yeah, and I mean the bug itself is just kind of funny too. Like only works when you call this incorrectly.
I just love those functionalities. I've encountered them a couple times where it's like it's either a function where if you call it, no matter what way you call it, it crashes, or you can only call it in a way that's exploitable. Like it just makes you wonder, is anything getting tested? Because it's a really bad sign. Like if there's code there that cannot be used correctly, there's some some things that need addressing in the development, or yeah, the development methodology. Like there's something weak there that probably needs to be addressed if those kinds of functions are making it in.
So that is true, but another thing I've thought of is could you imagine being a like not the VirtualBox developer, being another developer and you're wanting to use this driver and you're wanting to use this function and it keeps telling you that your ID is out of range and you can't figure out why because it's definitely in range. Like, can you
That'd be
imagine how
frustrating.
rage inducing this bug would be
Yeah.
to actually encounter? So it's like, of
Yeah,
course
like
it's
it's
got to
not
be
just a
me. I've
security
got to
bug,
be
it's a
doing
big
something.
usability bug. Yeah.
Yeah, like because this is the sort of bug where I would be like so sure I am doing something wrong. Like it's got to be me because it's so blatant too.
It's a gaslighting bug. Yeah. Yeah. So getting into another somewhat funny bug, we also have a PostgreSQL issue, which is an out of bounds access via array indexes, and it's when you get down to it, it's due to an int overflow. The proof of concept gives you kind of a gist of what's going on. They are decimal values, so you have to convert it to hex, but they are like int max, you int max, and two away from int max. And in this proof of concept, so they have the do statement where they declare an int8 array, and then they use those large values as array accessors. And this triggers a crash on hex 41, 41, 41 repeating. And they can also trigger a out of bounds read and leak contents by slicing the array and using a raise notice to read out of bounds contents. And that's because the array set element expanded function will try to do bounds checking on those values, but in doing so, they add one to the index. So, of course, int overflow can occur, which allows you to write at array at index -1, which overwrites the memory context, which by assigning a new value, you can get it reallocated, get an attacker controlled memory context dereferenced, or as mentioned earlier, by slicing the array, you can get the out of bounds read. So, sort of an interesting area to see a memory corruption, especially one that seems to be fairly exploitable from that context. Being able to get a read there is very powerful, actually trying to attack something that's using Postgres if you have that level of access. So, yeah,
Yeah, like
one of those areas you don't really expect to find memory corruption, but it happens when you're using C.
yeah, like this is definitely like the level of access you need on this is a like in the context of Postgres isn't very high because like generally your users able to query, but generally like you don't have access to run arbitrary queries on just any old server. So like,
There's
there
generally going to be
is
some front end on it. Yeah,
yeah, like generally it's an application that's using and you don't have that level of access. But it's still a really cool bug. Or a really fun bug at least.
yeah. So that's basically all the issues that we had for this week. Like I said, it was a fairly light week. There wasn't a ton that was put out.
Yeah,
We do have
unfortunately,
some.
both of these actually came from secure Google security research. So, we had cve-rs, but yeah, both of these kind of came from the same thing, um, which was just a new source. So, fortunately, I got something to talk about from it, but really kind
Yeah,
of hurting these last couple weeks.
yeah. It's been a little tough. But we do have some shoutouts as well. So Tutorial Boy had put out a post on analyzing Google Chrome, like a V8 out of bounds write. This was a fairly interesting bug in the maglev JIT engine for V8. Now, unfortunately, I tried giving it a read, and there's a lot of terminology and stuff here that's just, it kind of goes over me. Unfortunately, those who have been listening to the podcast for a while have probably picked up on the fact that we used to cover browser bugs with some regularity, and then we just kind of stopped because they've grown to a point where I don't really understand them too much anymore. I'm kind of falling out of date with browser exploitation meta, and it's just really hard to cover in like a podcast format because there's so many intricacies and so much that's exclusive to browser. Like browser, I've said it before and I'll say it again. It is pretty much the most complicated target that you can have, I think, for doing vuln research. So there's a lot of stuff here that makes it difficult to cover, so that's why we're not covering it as a full topic. But there's also a lot of background information that even touches on stuff that we've talked about a bit before on the podcast. Like we mentioned about V8's sandboxing, like sandbox pointers and stuff. And this blog post goes into explaining some of that and how that works. So if you're interested in the browser stuff, or even just find some of that curious, like I think this is a great post. It's very well written. A lot of it is easy to follow until you get to the maglev section. That's kind of where I had to hop off. But those who are more familiar with the JIT and the terminology there will probably be able to follow that as well. And it's always fun to see browser bugs, and they're always really interesting. But yeah, it's just difficult for us to cover, so that's why it's a shout out.
Yeah, I know there are people here that are more onto the browser exploitation, so I at least try and include these as shout outs when I come across, but it's not something I can also, or like Spectre, I can't really cover this too well either, so it's got to be left as a shout out.
Yeah. And the last shout out we have is from Trail of Bits. I feel like we've been covering Trail of Bits stuff quite a bit lately. But this is a post on continuously fuzzing Python C extensions. So, focusing on fuzzing areas that aren't really being talked about or focused on as much. Like it's very common to fuzz like C only code bases, and there's been a lot of attention put on that. But with Python and Python C and stuff, those areas aren't really focused on as much. So that's what this blog post talks about. They talk
Yeah,
a
and
little bit
it's
about a-theoris. I don't know how to say it, but it's Google's fuzzer for like Python code and Python C extensions. So yeah, there's some stuff here that I think is fairly like probably not known by a lot of people. So
yeah, and it reminded me a bit of a post we covered probably back in like 2019, like really early on, which was about fuzzing the glue code between like, Python, and when it's going to call into C, there's this little bit of glue code that's translating like the Python objects into like the C objects that can actually pass along and stuff. And like, just that glue code. It was about fuzzing there. So this almost feels like a bit of a, I mean, it's not a continuation of that in any sense, but a similar thing where it's just this area of C that maybe you're not necessarily thinking of where, while it is, fuzzing the C extension, there's going to be a lot of cases where these bugs just aren't very reachable by end users. But there's a relatively good chance that user input could flow into them coming in through Python, coming in through some Python apps. So it's an interesting area to take a look at, to consider for fuzzing. And in terms of covering Trail of Bits a lot lately, yeah, they've been putting out some good stuff. And I mean, they constantly are putting out some content. So especially on these times when we're hurting for content, they have a better
it's a
chance of
blessing.
coming up. Yeah.
Yeah.
Yeah, I mean, by no means am I trying to downplay like, oh, we wouldn't cover up normally or something. Like, I really appreciate their content.
Yeah, Trail of Bits puts out a lot of really good stuff, and part of why I like to recommend it too is they're good at breaking it down for people who aren't necessarily familiar with the subject. They go through a lot of effort to make it digestible for people that are on the outside and giving them the necessary background information. And this is another post that does that. So we just it's a very easy recommend. So yeah. So with that said, that's all the topics we had for this week. So we'll wrap it up. And yeah, thanks everyone who tuned in. Feel free to join the community by joining our Discord and Twitter. Links are in the description. And again, if you see any topics we might have missed, feel free to leave them in there because, like Z said, the last couple weeks have been a little bit tough on that front. So any help on that would be greatly appreciated. And we'll see you in the next one.